In these notes, we're going to be talking about the vertical circular motion of an object. And here I've drawn a ball that's traveling in a circle, and there's a string pulling on it in towards the center, so that this keeps traveling in that vertical circle. And at each one of these points here, we have to realize what forces are acting on the object and how to handle these situations. So if we go to the top, we know the force of tension is in towards the center. We also know that mg, its weight, is downwards. You can call it F sub g if you want. And if you were to take a look at this, look at the equations for this, you would say the sum of the forces equals ma. This is a y direction problem. And so we would have negative force of tension minus mg equals, now this is a negative centripetal acceleration that's pointing down towards the center, so that's a negative sign also, negative mv squared over r. And so that's the basic idea behind this is for the top section. Now if we go to the bottom section, we know the force of tension is up this way, and mg is down that way. And so when we go ahead and look at the bottom, and look at the sum of the forces equals ma, and again, this is in the y direction, we can see that our force of tension actually is up in the positive direction. Force of tension, our mg is down in the negative direction, minus mg equals, and again, our centripetal acceleration, which always points towards the center, is upwards in this case, so that's a positive mv squared over r. And so now we just take whatever givens we have and just apply it to that situation. And the sides are both the same, whether it's the left-hand side or right-hand side, are very similar to each other. If it's on the right-hand side here, we have the force of tension in this direction, and towards the center, and we have mg down. Now, right on that side, that weight has nothing to do with the centripetal force. At these two other positions, at the top and the bottom, the mg was involved in the centripetal force. And over on the left-hand side, we also see that force of tension in towards the center, and mg straight down. So in those cases, what we do is this. For the side, we say sum of the forces equals ma. The only force acting on the side is force of tension equals, this is mv squared over r, because this actually is an x direction problem only. So in that case, we would look at the problem with this situation here, with this equation here. Now, if it's at any other point, you would actually have to break up the forces into the components and work at it that way. But for today, we're just going to look at this situation here. And there's a problem I'd like to take a look at. Here's an example. In a 1901 circus performance, Allo, Daredevil Diavolo introduced the stunt of riding a bicycle in a loop-the-loop. Assuming that the loop is a circle with a radius of 2.7 meters, what is the least speed Diavolo could have at the top of the loop to remain in contact with it there? So what we have here is a vertical circle problem. We have at the very top is our person, and we want to know what the least speed could be at that top. So what that's telling us is that normal force there is 0. Now let's go ahead and take a look at the forces that are acting. At the very top, this person has a normal force instead of the force of tension, which is a normal force. And then we have mg pointing down as well. And now we'll go ahead and work and look at sum of the forces equals ma. We have negative vertical force minus mg equals mv squared over r. And I have to remember to make this negative because that centripetal acceleration is down towards the center as well. Okay, so let's go ahead and we also have to realize that the normal force is 0 because they want the least minimum speed that it takes to go around the circle. And so now what we, and the mass is, and actually we have, now we have mg equals mv squared over r. our masses now will cancel, and we end up with that velocity is square root of rg. And if we go ahead and plug in our values for r and our value for g, that'd be our velocity is 2.7 times g is 10. So our velocity ends up equaling the square root of 27 meters per second. So this is how a typical vertical circle problem